Okay, so welcome to this next lesson on something called the distributive property. Okay, this will probably be our last video topic for Unit 1. And the distributive property ends up being really important in a lot of our different units in algebra. So I think it's important that we really develop a strong understanding of it and are able to use it. So the statement of the distributive property is fairly simple. It says this. It says for any numbers, and we're going to use letters to represent them, A, B, and C. We know that A times the quantity B plus C, right? So we've got an A on the outside of the parentheses multiplied by a B and a C on the inside. We know that that's equal to A times B plus A times C, okay? And it works with subtraction as well. But basically what happens is we have an A on the outside, and we multiply it by a B to get A times B, and we multiply it by a C. So that's why we call it distributing, right? Because the A gets dropped off at each of these terms. It also works for division as well. So let's say we have B plus C divided by A. Well, that's the same thing, right? So I'm just going to do B divided by A plus C divided by A. Okay, and that works for any numbers. Here, since we're dividing by 0, the A cannot equal 0. Okay, so quick example to kind of show that it's true for at least one set of numbers. So I'm told that A is 4, B is 8, and C is 2. So I'm just going to substitute in to this equation here, and we're going to see if it's true. So we've got A is 4, 8 plus 2. Okay, so let's actually calculate this. So I know that 8 plus 2, right? When I'm working with an algebraic expression, I'm always going to work inside my parentheses first. 8 plus 2 gives me 10. So this just simply becomes 4 times 10, and 4 times 10 is 40, right? So now we want to test to see if the other side, if it works, then that kind of shows us that, that's an example of the distributive property. So AB means A times B, so it's going to be 4 times 8. And A times C is going to be 4 times 2. So 4 times 8, right? Now I'm going to multiply first, 32. 32. Plus 4 times 2 is 8. Okay. So now I've just got 32 and 8, which add to 40. So I see that, 40 does equal 40, so that checks out. The other example I want to show just shows how we use the distributive property to multiply numbers anyway, right? So this is probably a strategy that you've seen for multiplying in middle school. And it's going to be our second example here. So let's take this multiplication equation. Let's take 4 times 13. Okay, now a lot of people may even skip this step, but if you really think about it, the way that most people multiply this is really by doing this. We take that 13 and we think of it as a 10 and a 3, right? And then I do 4 times 10, 40. 4 times 3, 12. And then when I add them, I get 52, right? So, by thinking of the 13 as the sum of two numbers, 10 and 3, it makes my life easier when I go to multiply these larger numbers. Okay? So, this isn't something that you necessarily need to know, but I think it's helpful as we look at expressions like this to understand where that distributive property is used. So what we say here is that this expression is in factored form, right? So I've got a 3 on the outside and an x minus 5 on the inside. So to simplify this, all I have to do is I'm going to take my 3 and I'm going to distribute it to every term, okay? 3 times x, 3 times negative 5. So 3 times x, right, is just 3x. And 3 times negative 5, right, is negative 15. Okay? And these, this is important. These represent the same exact expression. They are equal for any value of x. So same thing here, right? I'm going to do 4 times 12, giving me 48. Okay. And then, I still have a minus, so I'm going to do 4 times y, or 4 times negative y, giving me a negative 4y. Having a little trouble with the handwriting here. And then this last one is slightly trickier, but the process works the same exact way. 2x times x, right? So I have an x times x, which is an x squared, and a 2, so this becomes 2x squared. And then, 2x's times 3. Now, since I'm multiplying, I don't have to worry about like terms. I just multiply. So 2 times 3 is 6, so this is minus 6x. Okay, now that I have this, I've thought of one more example that I want to show you. Let's take the expression 3 times x plus y minus 4, right? So, I can still use my distributive property even though there are 3 terms in here. So I can do 3 times x, 3 times y, and 3 times negative 4. So 3 times x, just like it was last time, it's still a 3x. Okay. 3 times y, right? But it's a positive, so positive 3y. 3 times negative 4 is negative 12. Okay? So that's taking an expression in factored form, right? In factored form, and writing it in distributive form. Let's write that down just so we're clear on this. So this is factored form. Right? And then when I apply the distributive property, I end up going into something that I just call distributed form. Okay. So, now I can go from factored form to distributive form, or at some point I might have to go the other way. So, if I look at 2x and 10, right, I basically want to write this as some term on the outside, and then I want to see what's left on the inside. Okay, so I know I'm going to have a minus in here, so I'll just bring that on down. So if I look at 2x and 10, I know that I can divide them both by 2, right? So that 2 is going to come on out to the outside. Well, now I kind of have to think backwards, right? Like 2 times something has to give me 2x. Well, 2 times x gives me 2x. That wasn't too bad. And then whatever's in here, I know that 2 times that would have to give me negative 10. So I know that that's going to be a negative 5, right? So this is just the factored form of the original expression. And if I get stuck, I can go back and check it. 2x, 2x, 2 times negative 5, negative 10. Okay? So let's take a slightly trickier expression. 10x minus 20y. Well, this one here, if I look at 10x and 20y, I know that I can divide both of the coefficients, both of these numbers, by 10. All right, so let's pull that 10 to the outside. And then think about what has to be left on the inside. Well, 10 times, this is just going to be an x, right? And here, 10 times something has to give me 20y. Well, that's clearly going to be 2y. Okay? So not so bad. And it's pretty much the same technique. We just have to pull out this larger factor here. Just in terms of vocabulary, we call this number that we pull out the greatest common factor. Okay? And 2 is also my greatest common factor. Alright, so then we go over here to this expression, which looks tricky, but I pretty quickly see that both terms, let's go back to pink here, both terms have a b in them, so that's going to be my greatest common factor. And then filling this one in is a little simpler, right? Because I have b times something has to give me AB. So that's just going to be B times A. I have a minus sign. And then B times something has to give me 4B. Well, that's just going to be 4. Okay? So what you should see here is that, this process goes both directions. So I went from distributed form sorry about that little interruption, distributed form, right? And I took that and I used this idea of greatest common factor to get it into factored form. Factored. Sorry about those buttons, guys. Form. Okay? So, thank you for watching the video. I apologize for the technology issues. But hopefully, having watched this, you should be all set to do the homework problems. Thanks for watching.